Welcome back. This is Yuri with Ormond Software, and in this video, I will be walking through incrementally more complete application of code engine features within an application and how that reflects on first um, the aspect of integration, initialization, and configuration it within the application by the development team, as well as the maintenance of the simplicity in terms of its use. I will be demonstrating this on an example of three different applications I created recently. This will be demonstrated based on today's build. This is still local. I will be publishing this build as a next major version, uh, possibly four. I think it's four to NuGet. But for now, just wanted to record a really quick video of how you would incrementally build up Code Engine out of the box features and what you would add essentially to your application and automate within your application and therefore reduce the workload on the development team. Um, the more complete that solution is, the code engine. So let's see. The first application is just a web API application I created for demonstration purposes. I have added, first of all, the package, the code engine package. Ignore the version number. This is a local build, so a local NuGet package. Next, I have set up the initialization logic for the code engine, and this is something you've seen in other videos. And if you would like more details on the initialization um, configuration, you can either visit the GitHub page or project page, or also watch the how-to video. So essentially, I am instructing um, the application to use code engine. First of all, I supply some essential parameters. One of those parameters is a provider. What is a provider? A provider is an implementation of an iAction provider. This is a contract that enables Code Engine to ingest, or rather to request and retrieve certain subsets of subject actions, collections of subject actions based on the subject type and an optional key that the consumer or the injector is trying to resolve. Um, so the implementation, I have to provide the implementation as a developing team, in this case, of this hosting application. I have to provide the custom implementation for Action Provider. Why? Because the only thing that I'm using of Code Engine is that basic package that only offers three main functionalities, core functionalities. The compilation of custom logic into assemblies, and then caching of those assemblies, and then injection of those assemblies throughout the hosting application. Um, so the custom implementation of the action provider has a requirement of having the retrieve method. The retrieve method, as you've already seen in other videos, has two parameters really. One is required type parameter. This is a subject type for which the actions are being requested. The other one is a key, string key, and this is equivalent to or is being used as a key or name for named or indexed resolution, let's say in dependency injection containers such as Autofac. Um, in this case, though, my implementation, just for demonstration purposes, is very simple. I'm simply checking whether the type is a simple subject, and if it is, I am supplying a list with a single subject, simple subject action with the name do something and certain logic to set the subject's data property to a bunch of ones. Now, since the subject type is simple subject, you can see that data property is the only property that it contains. It is settable, and so I should be able to run this logic and and um, and see the result. Now, before we do that, though, let's take a look at the endpoint, the test endpoint that I created. As in other examples that I had already in other demonstrations, this is a very simple. This is the consuming side of the code engine. The initialization and configuration is the essentially what developers would do to animate the code engine. This, the injection of either iExecutor or iExecutor Factory, is the consumption of the code engine. And just based on the simple subject, based on its type, we should be able to get an executor that will execute the string custom logic that we have set, setting the data property to a string value of a bunch of zeros. And then we should be able to take the data attribute value after that execution and return it back out of the endpoint. Let's kick it off and see if what we are expecting. Just a second. Oh, I think I think I haven't. Oh yeah, of course, this app is still running. Okay, this was an app from a prior demo. Okay, let's try to do it again. Try to do it again. It couldn't allocate the port, and so it failed, and in essence, it just showed the other app's screen. So we have web application 2. We have just one endpoint. Let's try it. And you can see the response body contains a bunch of ones, which is what was returned out of the result of running the custom logic. Excellent. This is the simplest implementation of only core components of the code engine. Let's look at the next step. In the next step, I would add what's called the abstraction, storage abstraction layer. And this is the engine.storage package. Um, what this package gives us is the ability of management and validation and um, versioning for the subject actions. Let me actually, okay, take one down, take that one down. Okay, all right, I'm back. All right, so let's take a look at the initialization logic. The initialization logic changes slightly with this. I no longer need a provider, my own implementation of provider, because I now use the abstraction that registers a provider, an out-of-the-box provider for the code engine. Oh, that's great. I do it with this use code engine storage. Now, code engine storage has not a requirement, but an optional parameter storage adapter. And what this storage adapter is essentially the connection between the data layer, be that a cloud storage or a file system or a relational database, um, and the abstraction storage layer. So it essentially says this command initializes the abstraction and configures abstraction storage layer. And then it says, okay, I'm going to use this connector to retrieve or write the actions, serialized actions, to some sort of persistent storage. Oh, that's great. Let's look at what we are doing here. We have an implementation for the storage adapter, as already said, I'm providing that. And Just for this demonstration, the storage provider, well, even though it requires to have two implementations for two different methods, I don't really need the write method. I'm not using it today. I need only the read method and only have it working for just a single subject type, which is the simple subject. I'm not using keys, and so I don't care about that. The only thing I do is check for the subject type. If it is simple subject, I use storage abstraction layer components to actually build the the iStore subject actions um, object, which is a collection now. This is the abstraction um, layer representation essentially in terms of the iStored subject actions. Um, so actions equals newed up stored subject actions. This is in itself a collection, a collection that is able to create new actions that we then update and activate. Now, it may or may not be required to activate. I will tell you a bit later what this actually means. You would not normally use it alongside with update or create. In this case, I do just for the demonstration purposes. Okay, what are we creating? We're creating do something action, and we're setting a data simple subject data property to all twos. And you see that I have additional properties here, and this is for versioning. With each update or creation, there is a new version created. This is all offered by the abstraction layer. And each new version, the versions cannot be um, removed, cannot be cleared. They can only be appended. And so every next version is being created, is then being activated, and then normally, and then used as current version. So what I'm doing here really is adding a new version or a new revision, to use the terminology um, for Code Engine. And then I'm just returning out of this adapter, I'm returning the list of actions. This essentially this interface, which is a list, a collection of a collection of stored subject actions for simple subject type. Anyways, how do I use it? Well, in terms of controller injection, the very same way. I have an endpoint to test the result of the setup, and I have executor injected here. I am executing the executor against the simple subject, and then I pass on the result of the model to the page. Um, the page simply, here we go, simply outputs the data property of that model. Let's run it and see what happens. And so at this point, well, it's starting. So at this point, I am using the components, the core components of the code engine. I am also using the storage abstraction layer, which helps me manage the the data integrity, all of those constraints and rules that need to be validated in a much easier way using concrete implementations and contracts offered by the storage abstraction layer, um, and making it easy for me to manage the action updates or retrieval. So, all right, so here we go. The page generated a bunch of twos, and that is because I had um, the simple logic provided out of the storage adapter as data set to a bunch of twos. Excellent. Let's go to the next step now. All right, not version, web application 5. With Web Application 5, I am using all currently available packages. The core functionality of Code Engine, then the abstraction layer for storage, and then also a storage adapter. So in this case, as you already guessed, I'm I'm supplying a storage adapter provided by the Code Engine, and using that instead of my custom implementation of such. The initialization logic changes slightly again. You will notice that as in a previous example where I used, um, or unlike as in a previous example where I used a custom implementation of the storage adapter here with this use code engine storage, I no longer have it. I don't supply it. I simply say, okay, let's use the out-of-the-box storage abstraction layer. Then I also use, because I added the file adapter package, I am able to use a use code engine file adapter. This is initialization logic for a file out-of-the-box file adapter. A couple of parameters it takes to have it um, configured properly, and that's all. This, what stays with the application, is just a simple subject model and well, logger. I haven't really done anything with logger. Let's take a look how this is used. You will notice that besides the usual test endpoint, where I inject executor, execute it, and spit out the result, I now have a create and update and activate endpoints, which have injected iAction storage contract. So this contract becomes available with the um, the abstraction layer and adapter being well, really adapter for this specific contract, adapter being available and registered and configured in a startup. Why I have to use this is because I don't have any way of providing, or I really don't want to provide any custom implementation where I would handle all of the CRUD operations and storage and data layer and all that interaction with data layer. Instead, what I have is this contract that now implements, it has the implementation out of the box implementation of the file adapter for the storage layer. And all I say here, what I can do is I can simply add action. I can get actions just from, I can update actions. And all this still works with versioning and everything else. And you can see I can activate revisions. Let's see how this works. We'll give it a second. And what I want to show you is, if you noticed, the TMP demo was the root path for the storage. This is a file system. And so TMP has nothing yet. It doesn't have the demo folder. So what I'll do first is I'll execute this. This is the execution part of it, part of the test. And so it should execute, inject and execute the simple subject executor. And as you see, it has no response. Well, it's a 200 with no result, no payload. Let's cancel out of this. Um, let's create an action. So code is going to be subject, oops, data equals, let's use fours. Don't forget this is a Visual Basic syntax, so I'm not using semicolons. Author, let's put my username. Name will still be do something. Comment, sure, I'll put something, but you'll see why this actually intentionally left it short. So let's see, execute. What's happened here? Well, we have an internal server error because it's unhandled at this point in a demonstration solution. But the message here is a validation message. The revision failed validation. Make sure your comment is at least 10 characters long. Oh, that's interesting. There is validation happening. And this comment really probably wouldn't make much sense. I can make it longer. I can make um, maybe action name, very short. Look at that. The minimum length of 3 for the action names. So you see that the validation layer absolutely adds certain um, restrictions, limits on what can or cannot be done, and that's all for maintaining the data integrity and proper naming, proper um, well, somewhat, just a comment of 3 characters probably doesn't make much sense. So there is a limit on that, minimum limit on that, for example. Um, anyways, um, rules in place and data annotation, other validation rules in place in the storage abstraction layer that um, um, help us with maintaining integrity of the saved and then retrieved subject actions. Anyways, what do we have coming back to us? This is what was created, a do something action. The code of the action is this, and the action has one revision, revision 1, it is active, and this is essentially the code that's reflected in the action. Great. We can probably jump back to the test endpoint and execute it. Oh, look at that. We have all 4s here. Great. If we want to update, maybe, well, let's see. Can I? Yeah, I can use just this payload, and I'll quickly update. Um, let's see, quickly update to all 5s and execute it. Excellent. That's good result. We have second revision. It is not yet activated, and this is to avoid um, unintended custom logic changes in a running application. The creation and activation of or update and activation of the revisions are 2 completely separate actions, ideally performed by different roles within the company. We have revision 2 now, though, so now we can go ahead and, well, maybe I should run this demo again and still make sure that we still have 4s. Great. Okay, then I will go and activate what? Do something action, and I will activate a uh, revision 1. No, I'm sorry, revision 2. Okay, so what happened here? Revision 2 is active now, and the code corresponds to revision 2. Now, if I execute the code, this is a great demonstration of caching. I took less than 1 minute to make the updates, and as you saw here, the cache expiration is 1 minute. So I'm gonna need to wait a little bit. That makes my um, demo a little longer. There we go. It expired, and now it got recompiled with a new logic and injected into the controller and executed. So this concludes the demo of 3 different scenarios and 3 different iterations of the incorporation of code engine features into a solution. I hope this gives you a good starting point if you wanted to add it to your application. I welcome any feedback. Thank you for watching this video, and I hope you'll be back for more. Thank you.